Hello friends, I am Dr. Himani Garg, working as professor in Department of Electronics and Communication Engineering in Ajay Kumar Garg Engineering College, Ghaziabad. Today I am going to discuss about handoff strategy. That is very important concept used in cellular system for mobile communication. As we know, in cellular system, each area is divided into cells and each cell is having its own base station. So whenever a mobile station moves from one cell to another cell, then there is a change of control from one base station to another base station. At that point, handoff strategy is required. So we will discuss about this handoff strategy. My contents will include handoff, types of handoff, classification of handoff, and strategies that are used for handoff. Now, what is handoff? When a mobile moves into a different cell while conversation is in progress, the MSC stands for Mobile Switching Center, automatically transfers the call to a new channel belonging to the new base station is known as handoff. So it is clear from this definition that handoff means the decision is taken by the MSC, Mobile Switching Center, whenever there is a call going on within a particular cell and that mobile station moves to another cell, then Mobile Switching Center will change the control from one base station to another base station, and this term is called handoff. Handoff operation not only involves identifying a new base station but also requires that the voice and control signals to be allocated to the channels with the new base station. As when we are in a particular cell, we are under the control of that base station, we have been assigned voice channel as well as control channels. So whenever we move to another base station, then that base station will be providing us with new voice channel as well as control channel. Handoff must be performed successfully and as infrequently as possible. So whenever it is, handoff should be provided only when it is required. Whenever a mobile station moves from one cell to another cell and it is not under the control of the base station of earlier cell, only then handoff should be done. Otherwise, if you are having multiple handoffs, then it will increase the burden on the MSC, that is the Mobile Switching Center. For this system, designer must specify an optimum signal level at which to initiate a handoff. As whenever we are using a mobile, then there is a power level of the signal with a particular base station. If that power level drops below a particular value, only then handoff should occur. So we will have to decide, in the designing part, we have to decide what is that power level at which handoff should occur. Once a particular signal level is specified, that is the particular signal level for handoff, the minimum usable signal for acceptable voice quality at the base station receiver, a slightly stronger signal level is used as a threshold at which the handoff is made. So we are talking about two types of signal. One is the minimum usable signal and another for acceptable voice quality at the base station. There is a minimum level of the signal that is acceptable by the base station for the voice quality that is required. A slightly stronger signal is required as threshold. So the threshold will be a higher signal and we are having another signal that is lower in value through that, at which we are having a basic property that the minimum quality of voice is achieved. This margin that is called threshold is given by, this is noted by delta, and where this is the handoff power, that is the handoff power at which the handoff should occur, minus this PR, that is the minimum usable power signal that is required for quality of acceptable for voice quality. So delta is the difference between this handoff power as well as the minimum usable power. So we have to decide that the handoff should occur within this range delta. I will explain it with the help of this example. You can see here, just look here. Here you can see there are two cells. This cell 1 and cell 2. This cell is having base station 1 and this cell is having base station 2. Now, this is one mobile station that is in cell 1. This mobile station is in cell 1 and A is the point that is near to the boundary for moving to cell 2, and this shows the power of the signal with the base station, Now, you can see here, this mobile station will be moving to another cell that is under the control of different base station. So whenever this signal is moving whenever this mobile station is moving from point A to point B, then you have to monitor the power of that particular signal, and then you have to decide when the handoff should occur. Now, there are two situations have been given here. First situation is for improper handoff situation, another is proper handoff situation. Now, improper handoff situation is given in this diagram. You can see here on the x-axis we are having the time domain. On the y-axis we are having received signal of the, this is the signal of the mobile signal between the base station and the mobile station. Now, at this point A, that is at the boundary of cell 1, you can see this line shows the power for A, and for B, this is the boundary line and the cell B, and this is the power level. Now we have to decide, as the mobile station is moving from cell 1 to cell 2 at point A and B that are close to the boundary. So the mobile switching center should take a decision whether there should be handoff or no handoff. In an improper handoff situation, we will see what will be there. Say, so A, this point shows the level at point A, the received signal level at point A. This is the handoff threshold. In the last slide, we had discussed that there are 2 points. One is the threshold level, another is the minimum usable level. So this is the handoff threshold level, and this is the minimum acceptable signal to maintain the call. So the level of the signal should not drop below the minimum acceptable signal to maintain the call. So the decision has to be taken within this range. Within this range, the decision has to be taken. As you can see in the improper handoff situation, the signal has dropped below this minimum acceptable level. Until then, handoff has not occurred. So there will be level at point B at which the call will be terminated. As the signal level has gone below the minimum acceptable level of the voice quality signal, so that's why the call will be dropped, and in this case we will call it as improper handoff. And what is the proper situation for handoff? You can see here the same 2 levels. This is a level at point A, and this is the level at point B. Now the decision for handoff has been taken within this range, and the call is continuing at this point B. That means proper decision has been taken, proper handoff is there. That's why the call is not terminated. And when the user moves from one cell to another cell, it is coming under the control from changing the control from base station 1 to base station 2 within this particular range, and its call will not be terminated. So this is the case for proper handoff situation. So we have to decide within this particular range. So this is how the proper handoff should occur. Now, the delta that we were discussing about can't be too large or too small. We can't consider the value of delta, as we have to design the system. We have to take the decision. We have to set the value of threshold level and the minimum power that we have to see. So delta should be decided. So its value should not be too large or its value should not be too small. Case 1, if delta is too large, what will happen if the value of delta is large? Unnecessary handoffs are there which burden the MSC. If delta is large, then the range will increase in which the handoff should occur. So there will be multiple handoffs, and if there will be multiple handoffs, then MSC will keep on doing this handoff condition will be there, handoff, he will keep on doing the handoffs, and that way it will be there will be burden on the MSC. But in the case if delta is too small, if the decision taking region is too small, then what will happen? There will be insufficient time to complete a handoff before a call is lost due to weak signal conditions. That means there will not be a proper handoff from one base station to another, as we will not be having a proper time, as the range is very less. So the call may be terminated. Call drain condition. Now, call drop event can happen. Now, when the call drop can happen? Case 1, when there is an excessive delay by the MSC in assigning a handoff. As the decision has to be taken by the MSC. If MSC delays in giving the decision that handoff should be occur, and he should provide some channel to the upcoming mobile station, then there are chances of dropping of call. Excess delay. Now, why this excessive MSC? We are saying that there can be delay at the MSC part, but why there can be delay in the MSC part? The reason is high traffic density. At the mobile switching center, as he has to take a decision for handoff, but the traffic at the MSC is too high. There is high density of traffic is there due to computational loading at the MSC, then there are the chances that the call may be dropped. Second reason, due to the fact that no channels are available or on any of the nearby base stations. So, as there may be depletion of channels at the base station, so the MSC will not be able to provide channel to the coming user. So, that's why there may be call drop. Now, case 2, when the threshold delta is set too small for the handoff time in the system. The reason for call drop may also be that delta has been assigned too small. This is the reason that we had discussed in case 2 also. Now, another term that is used in mobile system in handoff strategy is dwell time. What do we mean by this dwell time? That time over which a call can be maintained within a cell without handoff is called dwell time after the handoff threshold. Handoff threshold, the signal has gone below the threshold, but even then there is the call is within a particular base station. That particular time is called the dwell time for a particular base station. So now we are going to discuss about the type of handoff. First one is intra-cell, intra-BSC. Intra-cell, intra-BSC. Inter-cell, inter-BSC, inter-MSC handover. So we will discuss about this one by one. First is intra-cell, intra-BSC handover. You can see intra, within a particular cell, you are having then same BSC is there, same BSC is there, same cell is there. So the mobile station has been assigned from old channel to new channel has been assigned. That means handoff has occurred. Such type of handover is called intra-cell, intra-BSC handover. Second is inter-cell, intra-BSC. Now you can see intra-BSC means there is BSC is there, two cells are there. So inter-cell and intra-BSC, as they are controlled by a single BSC. So whenever there is a change of their handover will occur from one cell to another cell controlled by the same base station, then that will be termed as inter-cell, intra-BSC handover. This one is inter-cell, inter-BSC handover. You can see two cells are there. So the handover will be inter-cell and two MSCs, BSCs will be there. So it will be inter-BSC. So inter-cell, inter-BSC handover there. The subscriber moves from cell 1 to cell 2, which is served by another BSC. Such type of handover will be there. In this MSC, handover process is carried out by MSC. So you can see here the control will be by MSC. In the previous picture, there was no role of MSC, whereas in this case, the control is with the MSC. But the decision to make the handover is still done by the BSC because the power is being monitored by BSC. Traffic connection with the first BSC and BTS is released when the connection with the new BSC and base station is set up. And so the connection that will be released with this base station will only occur when the new connection has been set up with the next base station. Now the fourth one, that is inter-MSC handover. Now you can see cells, two different cells are there, two different BSCs are there, as well as two different MSCs are also there. So this is controlled by GMSC. The subscriber moves from cell 1 to cell 2, which is served by another MSC. In this case, the process is carried out by GMSC. Traffic connection with the first BTS, BSC, MSC. So the whole control BTS, BSC, MSC is released when the connection with the new BTS, BSC, MSC has been successfully taken over, set up. Only then the handover will take place. Now, classification of handoff. Now, the handoff can be classified as soft and hard handoff. So, we will discuss about this soft and hard handoff. Hard handoff, soft handoff, hard handoff, also known as break before make. We should be clear about this term. Hard handoff means break before make. So, that means the connection with the first base station will be broken first, and then the connection with the new base station will be made. So, this is break before make. It is one in which the channel in the source cell is reduced and only then the channel in the target cell is engaged. So, you can see here breaking. So, the control is going from cell 1 to cell 2 when the mobile station is moving from A to B. So, breaking, there will be a break of channel. Cell 1 has assigned a channel to A that has been broken, and then new channel connection from new BSC has been assigned. So this type of handoff is called hard handoff. Thus the connection to the source is broken before the connection to the target is made. Hard handoffs are intended to be instantaneous in order to minimize the disruption. So this should be instantaneous, otherwise the call disruption will occur. It is not necessary, there is always a connection between base station and mobile station. Next, another is soft handoff. Now the term should be clear, make before break. In that it was break before make. In this case, we are having make before break. So you can see whenever a mobile station moves from A to B, then the connection channel is not completely broken with cell 1 till the connection with cell 2 has been made. So this is make before break. So the connection with cell 2 is being made, and then only the breaking of the connection with cell 1 will occur. It is one in which the channel in the source cell is retained and used for a while in parallel with the channel in the target cell. Thus, the connection to the target is established before the connection to the source is broken. In this kind of handoff, there is always a connection between base station. Obviously, there will be always a connection between base station and mobile station. That can be with either with cell 1 or with cell 2. There will be always a connection, only then there will be handoff will occur. Now, we will discuss about the strategies of handoff. What are the different strategies? Network, the handoff can be network assisted or it can be mobile assisted. Network assisted means in network we are having the base station, we are having the mobile switching center, all these things are here. And mobile assisted means we are having a mobile set in our hand, and if the handover occurs due to that mobile, then it will be called mobile assisted handoff. We will clear about these things. Network assisted, that was used in 1G analog cellular system. In this handoff, base station constantly monitors the signal strength of each mobile user. Now, you can see here, network assisted in network assisted, we are having the base station that is continuously monitoring the power of the mobile station. You can see here if you call it, this is the base station, and here we are having your mobile station. Then this base station will continuously monitor the power of the mobile station, that whether the power of the mobile station has gone below threshold or whether it is above threshold, and report to the MSC, which makes the decision to hand off. If the signal goes below the threshold level, then it will report to the MSC to take the decision for handoff. In addition to measuring the RSSI, now what is this RSSI? Radio signal strength measurement. Radio signal strength measurement. So, base station is continuously measuring RSSI of the calls in progress with the cell, a spare receiver in each base station called locator receiver. Locator receiver. The mobile station, as the mobile station is moving from one cell to another cell to another cell, so there is a locator receiver also at the base station that will be monitoring the power of the mobile station. There is a spare receiver in each base station called locator receiver, is used to scan and determine the signal strength of the mobile user which are in neighboring cells. Why we are talking about neighboring cell? Because the neighboring cell mobile station can move to our cell. So that's why their handoff should occur when it moves from that base station, from the neighboring cell to the present cell. The locator receiver is controlled by the MSC and is used to monitor the signal strength of the user in neighboring cell which appear to be in need of handoff. Why will be need of handoff? Because that mobile station can come in their base station in their particular cell, and in that case handoff will be required. Now, second type of handoff is mobile assisted. Now, in this case, the disadvantage of that network assisted handoff is that mobile station MSC should be always active, base station should always be active for the handoff, for the purpose of handoff, and it will increase the burden on the MSC and the base station. So, in that case, we are using mobile assisted handoff, where the handoff decision has to be decided by the mobile station. In this handoff, every mobile station measures the received power from the surrounding base stations and continuously reports the result to the serving base station. Now, the mobile station continuously monitoring and then sending the signal to the base station, and handoff is initiated when the power received from the base station of the neighboring cell begins to exceed the power received from current base station by certain level for a certain period of time. So obviously, when the signal goes below a particular level, then he should inform the MSC or the base station that the signal level has gone down. MHO enables the calls to be handed over between the base station at much faster rate than 1G system that was based on network assisted handoff. Since handoff measurements are made by each mobile station and the MSC no longer constantly monitors the strength, therefore the burden on the MSC is reduced. That was the disadvantage of network assisted handoff that has been removed by this mobile assisted handoff. MHO is particularly suited for microcellular environment where handoffs are more frequently. In the microcellular environment, we know the whole area is divided into smaller cells or micro cells. So the handoff will be more. In that case, mobile assisted handoff will be of much use, as it will decrease the burden on the MSC. So that's all for today, and these are the references that I have taken. So thank you for watching.